So are we live?
Good evening, folks. Appreciate everybody joining us. We'll get started in a few more minutes, but let everybody climb on in. Let us know how the audio is. Let us know what you think. Let us know if you have any questions before we get started.
Jeez.
Hudsy, you still out there? See you in chat.
No, he's left.
All right. Sounding good so far.
Where are you guys chatting?
Twitch.
Which?
Oh, Twitch.
Yeah, you can hop on your other monitor if you wanted to. If we see somebody ask a question, we'll try to grab it. Usually John will present the question. But if you're also looking at it, then that would work great too.
Actually, that's going to be a problem because I'm going to hear myself. So I will turn that off. And you guys can tell me when things come in.
There is it is possible to pop out the chat as well if you just wanted to chat. But we'll catch questions.
Okay. So you guys tell me when you're ready for me to.
Yeah, we'll give it a few more minutes as everyone pops in.
I think it's settings, the little cog down at the bottom for the chat.
Here.
Yeah, and then there's a pop-out chat right there.
Okay.
I was going to say
Right,
we got another viewer, but that's Alan.
Well, Joe Zach retweeted us or retweeted, so I think he might jump in and look to kick Alan in the shins virtually.
Very nice.
So how is everyone's night going so far?
Who are you asking?
My arm hurts.
Clayton just had shoulder surgery, so we thank him for roughing it out for us, playing through the pain.
Oh.
Ooh, I should silence mine too.
Not muting his phone.
Anytime.
My day's pretty good. I've been in the seat almost all day now.
Perfect.
How about you? You left your office?
I went to physical therapy a little while ago.
Ah.
So I'm going to have surgery next week.
Where are you having surgery?
Tis the season. Disc replacement.
Oh.
It's second one. It's fine.
It's just another Tuesday.
I don't remember how many discs there are, but
I mean, eventually
I'm going to go solid. I'm going to go solid state soon. Sorry.
Oh man. Well, good luck and congratulations on coming through the other one, man.
Sure. And the other one was many years ago. So, well, 4.5, 5 years ago, something like that. So we are at 7:05. With that, I think we're about ready to get started. Wanted to thank everybody again for coming and attending. We are broadcasting live on Twitch. If you've got any questions for Alan or any questions that you want to ask during the broadcast or during the presentation, please post them into chat and we'll be sure to let Alan answer them. He's got his chat window up. If he misses it, then we'll call his attention to it. So be sure to ask anything and everything in there. If you want to send him a virtual kick to the shins, then please do so. If you enjoy this format, then let us know. We'll continue to try to do that monthly until we can get into a position where we can get back together socially in person. With that, we are always looking for more speakers, more topics, anything of interest that you might have. Be sure to let us know. Join in on the conversations in the discussion boards on Meetup. We've got a Facebook group if you're into that sort of thing. We do live stream the presentations to Twitch, and we back up the videos to YouTube as well. You can follow us on Twitter at saintpete.net. With that, I will let Alan take it away. Alan Underwood is one of the co-hosts of the Coding Blocks podcast, and looks like he is tweeting out for us and trying to get us some more viewers and subscribers. I have seen this presentation before. It is a great presentation. I know that, Alan, you actually did this one at NDC in London. Is that correct?
I did. It was a good time. Got to fly over there and revise this thing quite a bit from the time that you actually saw it. So hopefully there's some more information in there that'll help clarify things for people out there. So, and yeah, I didn't even think about tweeting this out earlier. So apologies for that last second thing. So, you know, whatever, maybe we'll get a few more people. So I guess with that then, yeah, my name's Alan Underwood. Like he said, I do codingblocks.net, another podcast along with six-figure developers. So if you like their content, come check us out. If you like ours, go check them out. You can find me on Twitter at the Alan U, or you can hit me up at Coding Blocks, either one. I look at those quite frequently. And I'm also a fellow Microsoft MVP. And ironically, what I'm going to be talking about isn't much in the Microsoft world here, although we are going to touch a little bit on SQL Server. So I guess let's go ahead and get rolling here. So first thing is the most important thing is donuts, all right? So typically when you think about making donuts, if you have a family, if you know anybody that's ever made donuts at home, this is usually what it ends up looking like, right? But more important than just the chaos and the mess that's going to come out, it's very much a step-by-step process, right? And in the world of data, we can think of this like batch, right? So you're going to roll out this dough, you're going to cut this thing up, and you're going to do this many times, right? So you're going to cut these things out. And then after you're done with that step, then you're going to take them, you're going to put it into the oil, you're going to cook these things only for like a minute on each side. It's actually kind of fun. After that, you're probably going to dip it in some sort of icing that you made. And again, it's all very manual. Hey, I got my 12 donuts here. I'm going to put it in this. And then the next step is I'm going to bake it, right? Which I accidentally skipped that. So it's very much a step-by-step process. And I've got a quick little video here that I want to share. I've got the YouTube link in this in the presentation, which I'll have a link to this GitHub repo where I have a lot of this stuff afterwards. But this is really short, but I want to demonstrate the difference between you making things in batch. And if you've ever gone to a Krispy Kreme, this is actually a lot of fun. It's kind of cool to sit here and watch this. So the way that they do it is they have this thing squirt things out as they're going, right? This stuff is running. There's no one person doing this and then standing on to the next thing. You see, this is on like a conveyor line. And now those things made their way onto these shaker things where they're actually going to rise up. And then the next thing is they're going to go down this river of oil. And when I saw this at the time when I was doing this, I was like, man, this is exactly how you parallelize things, right? Instead of having just one thing that's being done here, these things are all happening in a row, like continuously going through here, right? And that wall of sugar that's hitting that is probably the most important part of this process. So, like, this is kind of the way that if you could do everything, if you could make everything just work this way and turn it into parallel streams, that's amazing. Well, in our standard batch ETL world that probably most everybody's familiar with, at least people that have been doing this for a long time, right? Like you'll have a database, and then let's say that if you're working in any kind of business type thing, you're going to load data from some external source and typically on some sort of schedule. usually late at night when nobody else is on the system. You're going to load data. Let's say it's from a customer data warehouse. Then 2 hours later, you're going to kick off some load. Maybe you want to go get some social media information on your users, and you're going to load that at 2 a.m., right? And this was actually a copy and paste error from the first time I did it. I was like, well, I mean, Facebook has all your data, so why not load more data from them, right? So 3 a.m., you go and you go get some more. All right, assuming all that stuff finishes in time, then at 3:30, you're going to go run some processes in your database to transform, enrich that data, join things, do whatever you need to do to get some good information out of it, right? And then maybe after that, you're going to have another process, assuming that this thing finishes within the right amount of time, that you're going to kick off at 4:30, that's going to go do some more munging and creating of data. And then hopefully by the time it's all done, people get in the next morning and they can start working. They've got all their data for the reports, right? There's all kinds of things that can go wrong here. And if you've ever worked in this world, something failed here, something failed here, then all of a sudden, a lot of times it's not, hey, let me just go rerun this process, right? It might be, well, it's going to take 6 hours to get back up. So the data is actually not going to be ready until the next day. And so these are problems that people have faced forever. And one of the things I like to point out here is if you've ever looked at SSIS and some of their, data flows that happen in here, this is actually not even a big one, right? Like this is pretty standard for just moving a little bit of data around, but this can get really unwieldy over time, right? These get really large. So what's wrong with this? Really, maybe nothing, right? Like if people are getting the data in the time that they want to get it in, and they don't care about maybe having stale data, then maybe this is fine, right? You could just run this thing semi daily, maybe every 4 hours, every 8 hours, something like that. Nothing wrong with it. But, you know, what if it's taken too long, right? All of a sudden the number of users you have in your system or the amount of data that was coming in just doubles or triples, and all of a sudden what used to take an hour now takes 3 or 4 hours. That might be a problem. You have IO constraints, right? All of a sudden you're starting to write a bunch more data and your disk can't keep up because it's all on one system, right? Your SQL server or your database. You have locking contention. So as you're loading the table, you can no longer run updates because you have these blocks on the tables. The data isn't ready. So you go to pull that data from your data warehouse and they had a problem that backed them up. And so you couldn't grab that. That's another thing that can happen. And what if the data that you're getting is no longer good enough to be the next day, right? Like something happens and you need to respond to some sort of trend that just happened. That's not something you get in the batch processing, at least in the long running batch processes. And the primary database, this is another thing, man. And there's a saying, when somebody has a tool, when somebody has a hammer, then everything looks like a nail. And I don't think anybody would be shocked to hear that their SQL Server database is now, their transactional database, or reporting database, their, you know, everything, right? It's doing it all. And as you start adding more and more to it, the load starts getting heavier on it. And now you start having performance problems, not in just one area, but all of them. So, what is this Apache Kafka thing? If you've never heard of it, and it is actually Kafka, I had to look this up back when I first started doing this thing. Basically, all it is, it's a way to take events and put them in a single write only, append only mode, right? It's basically a distributed transaction log, more or less. And the cool part here is it's capable of handling trillions of events a day. And this isn't just, some pie in the sky thing. Microsoft is actually doing it. And if you go look at this particular link here, you'll see that they've got a cluster of 10 of these things that are handling for Office 365 and some of their other apps over a trillion events a day. And that's in Azure. It was originally created as a messaging queue, basically, not just like a RabbitMQ type of queue, but one that could maintain the state. So typically in a general queue, a message just comes in and then it goes out and then it's gone, right? This one, you can actually persist that data. And as I said, it's a distributed commit log. It was open source by LinkedIn in 2011. So this thing's actually been around for 9 years and it's got a pretty big backing in the open source community. And it evolved from a messaging system to a full-fledged streaming platform. And basically the reason it did it is because it's hyper fast. So typically what you'll see now is a lot of things will kind of hook into Kafka. So in the past, you would see things hooking into a single database, which means that you wrote a bunch of SSIS packages to move things in and out, right? But that meant that you had to set your source connections, your destination connections, and do all this stuff manually and keep all these things up to date. With Apache Kafka, you can set up your data to come in here, and anything that cares about it and has access to it can just subscribe to it. And as new data comes in, it automatically can do something with it, right? So it's no longer this thing where it's pushing out to everything in a fan out approach. Basically, anything that cares about it can subscribe to it and start getting that data. So it sort of becomes the backbone, as you can see here. Everything else is reaching in. So your data warehouse might push data in here, but it might also be subscribing to things. Same thing with Hadoop, SFDC, all that, right? So it's like a two-way street. So that all sounds cool. It's probably about time for a demo, or is it? So one of the things that when I first gave this talk, I think the problem is it's really hard for people to visualize what's happening, right? There's a lot of moving parts here. So I wanted to at least give like an introduction to what we're going to be talking about. So the first thing that I want to talk about here is, so behind the scenes, we got Kafka, right? That is the technology that is storing this data. To get data in and out of Kafka, you've got producers, which push data into Kafka, and you've got consumers that pull data out. Those are the subscribers, right? Those live here on the bottom. And you can see here, this says the flexibility goes up because you basically can custom write any of the code that's doing any of this stuff. But the productivity down here is a little bit lower because you are having to write all that code. As you go up this triangle, your productivity goes up, but these are more abstractions. And so what you can do up here is more limited than what you can do as you're moving down this thing, right? So your consumer and producers push and pull data out of Kafka. K-streams are this notion of being able to do streaming data into and out of Kafka, that basically you have an application that, let's say that you want to do some sort of ETL, or let's call it the T for the transforms on data that's going into Kafka. You can have something sitting here that subscribes to a topic. As data comes in, it grabs that data and starts doing whatever transformations you want to it, and then you push it back to another topic. KSQL is an abstraction on top of that that allows you to set up simple queries to listen to topics and then create other data off those topics, right? So let's get into this thing. Oh, and I didn't even realize I had these notes on here. So at any rate, I've already told you all that stuff. So moving on to this is what we're going to have set up in what I'm going to show you today. So here we've got SQL Server. I'm going to be generating data in SQL Server because basically what I wanted to illustrate here is how could somebody start bringing in something like Kafka into their existing world, right? In a lot of cases, we have a lot of transactional data that goes and lives and is sourced in SQL Server. So if we had data coming in there, how could we introduce Kafka to leverage that data and then do some interesting things with it? So first thing we're going to do is I wanted to point out here this pyramid we had on the other side here, the consumer and producer APIs. There's a technology called Kafka Connect that you can deploy, and it's basically a service that runs that allows you to sort of automatically hook up sources and destinations, or so basically pull data out of a source and put it into Kafka, or take data out of Kafka and use it as a sink to push elsewhere. And we'll visit that here in a second. But it's all configuration based. You don't have to code any of that. And I'll show you that as we go into this demo. So the first thing we're going to do, we're going to write some customer transactions into the database. After that, we're going to set up a source connector to basically say, hey, I want to pull data out of my SQL Server and I want to push it into Kafka, right? So as that data comes in, it gets streamed over into a topic in Kafka, which is basically just a persistent queue, right? It's write only. So as data comes in, it just keeps writing it to the log. After that happens, we're going to set up some source connectors. Actually, oh, wait, I take that back. So here, what's going to happen is I'm going to have these two things. I'm going to demonstrate these separately. So KSQL is what we showed at the top of that pyramid that can basically, you can write like SQL statements against these Kafka topics and have it automatically transform and do things with that. So I'm going to do that. As we get further into the demonstration, I'm going to show you K-streams, which is where you actually write your own Java applications. In my case, I wrote a Kotlin one that can take that data and do things. So they both do similar things, but you got way more control here. All right. So after that, I'm going to push data back into a topic from these applications. So if you're just reading data out of the topic, that might be useful if you're using it in your application. But a lot of times you want to also enhance that data as it comes back in. So in both these cases, we're going to push data back into Kafka. After it goes there, we're going to set up these source or these sync connectors that are going to take data out of Kafka and then push them back over into both of these. I want to take aggregations that I'm doing and push them into SQL Server. And I'm going to take those same aggregations that I'm going to push them into Elasticsearch. So the gist of it is what I'm doing is I'm writing detailed transactions here. And at the end of it, what I'm doing more or less is I'm summing those transactions. So then instead of doing these aggregate queries in SQL Server that most people would end up doing with a bunch of group bys and adding load to your server, it's going to do all those calculations in these two tiers over here. And then it's going to push those aggregations back over here so that you can take the load off your SQL Server and let it do its transactional stuff that it's really good at. So now let's do the demo. So let's exit out of here. And the first thing that I do want to say is I'm running all this with Docker. So if you follow along with this and you see this, I think I have a decent README up on the GitHub repo and the Coding Blocks GitHub where it'll tell you how to go about doing these things. So first thing I'm going to do is I'm going to Docker compose up this thing. All right, and this is going to start up my entire infrastructure. If you're not familiar with Docker, you should be. I would highly suggest getting familiar with it one way or the other because it allows you to do a lot of this stuff without having to install and set up these things on one computer, which can be an absolute pain. And if you've never seen what a Docker Compose file looks like, basically this right here, I've got Zookeeper, Broker, schema registry, all those things that you saw starting up here, they're like separate servers that I'm able to define in a file and it starts it all up. So all that said, we have this thing running now. So now I've got a few scripts that I need to run and I've got these set up in a way that hopefully makes it not too crazy to follow. So the first thing I'm going to do here is I'm going to run this command and you can see here, I'm calling into one of these Docker containers that's running one of these services, and I'm basically creating a topic. Now, this is important. You don't necessarily have to do this if you just wanted to get up and rolling. However, if you create a topic, if you let the applications create the topic for you, it'll create it with just one partition. I want to do 5 partitions because I want to show you how you can parallelize these streaming applications as they go. So I'm going to create this one. That one's done. I'm going to do this next one. Same type thing here, just creating a topic. And again, these are, I don't want to call them tables, but if you're from a database world, you can consider this a write-only table where you're only ever inserting things. And same thing for this. All right. So I've created these topics. They've all now got these 5 partitions, and I'll be able to show you in a second in a UI that these things are up and running. As a matter of fact, 90. Oh man, I'm gonna have to look at it. It's been a minute. These are running on. Where is it? Control Center, 9021. All right, so if we come over here, this is a thing that comes from Confluent. This is their own UI, and it might actually be different than this now because I haven't upgraded to the latest because it's never good to do that for a demo. But you can see here, I've got the source JDBC rewards, which I just created a minute ago. These, and you can see that it says replication, but these are the actual partitions, right? So I have 5 partitions, and we'll be able to see in a minute that data will start coming into these things. So that's first step. The next thing we want to do is we need to go do some of this stuff in the database because that's where, like I said, I'm going to generate these connections and these other things that are running. So first thing, I'm going to run this. We're going to create the database. And again, this is running in a Docker container, so you can blow it away and it goes out. All right, so we just created the streaming DB. That's good. Now we're going to create these tables. And real quick, just to review it, it's nothing major, but you can see here, I have this user reward. So this is basically the balance table, right? This is where the aggregates would come into play. The transactions are the things I'm going to generate on the fly, and each transaction is going to have some random number that gets generated between like 0 and 100, or between negative 100 and 100. But this is basically putting that stuff in there. And then the last one, the rewards real time. This is where I'm actually, so this table is going to be empty, but when I start bringing data back into SQL Server, this is the table where it's going to land in. So here we go. Let's run this. And here's another thing too. This is just a little tip. Anybody that's not used this, Azure Data Studio is amazing if you're trying to share things with people. Because if you're using SQL Server Management Studio, you can't make stuff bigger without screwing up your UI. So, it can be helpful. All right. So this thing right here, all I'm going to do is set up some initial balances for these users. It's nothing really all that special, but I wanted something to be working. All right, so these are my records, as you can see up above, nothing all that special. But here's where I'm going to do something, and this is kind of important. This is a very hacky way of doing this, but basically so we could see things happening, I'm inserting records. I basically have an endless while loop running on this thing, and I have it doing some sort of random between, I don't know, half a second and a second and a half or something when it inserts records. That way we can see this because it can go much faster, but it would be hard to show you anything. So I'm going to connect to this database now, and I'm going to start running this. Okay, so you can see it started executing. That's all good. Now I'm going to open up this thing, and we're going to run this one as well, just to show you what this query does, and we'll talk about it real quick. So in this is kind of what you would see in the real world for people who use SQL Server or any kind of database for all their stuff, right? We're going to do some sort of aggregation. We're going to group, we're going to sum the points, we're going to do all this kind of stuff, right? So here I'm going to say, hey, give me basically the point total that we've got here. We're summing everything. We don't care about whether it's positive or negative. Down here, we want to see how many people have redeemed, how many of their points have they spent. And we're going to say, hey, where the points value was less than 0. And so that's another one. And then down here, we're doing a bunch of left joins to get stuff together, right? But basically what you'll see is when I run this, that these are the number of transactions that have been created for that user already. This is my calculated point balance, which is taking what's in that user balance table and then doing any kind of aggregations on the points. This is where we're going to stream stuff back in. That's why it's null. We haven't set anything up yet, and etc. But you get the point there. So these are all happening. If I run this again, this should probably be higher than 10 at this point. So we can see that things are coming in, right? 10, 12, 10, 17, 13, 10, 18. So we have data coming in. Not crazy fast, but enough to where we can demonstrate this stuff. All right. So now it's time to go over into the streaming world. So Clayton, I think you were like, I don't want to see a ton of database stuff. That's about the extent of it. So we can move on from here now. So here's what we're going to do. So first, as I mentioned in the slides, right now we have data in SQL Server. It doesn't exist anywhere else. And I'll show you that. So I'm going to use this KSQL thing that was at the top of that particular food chain, right? So let's do this. We'll do this. So again, I'm running the command saying, hey, I want in that KSQL CLI container up here, I want to run this client. It's basically just a CLI interface for this thing. And can you guys see this okay? Like, is the zoom good enough on this? I can make it a little bit bigger. Let's see. Yeah, I mean, if I go too much bigger, we won't be able to tell anything. But all right, so here we go then. So check this out. We're in KSQL, and I'm going to show you something here. So this command is so important depending on what you're trying to do. So in Kafka, when you set up a consumer to go talk to Kafka, there's a thing called offsets that happen. And basically, if I were not to set this thing right now to say earliest, if I were to set up a consumer to listen to a topic, it's just going to get the data from that point when I joined. If I want to get all the historical data that happened before I joined that, then I need to set I need to set this, and that's what I'm going to do. All right. Now, the next thing I'm going to do is I can do all this. So I'm going to create this table. Do I care about this right now? Maybe I will. So I'm going to create this table over here. So check this out. This is kind of important. I'm going to create a table, which really behind the scenes is going to create a topic in Kafka because we're using KSQL. It's going to create these columns, nothing all that special here. But look here, it's going to basically say, I want to create a table in KSQL and I want to source the data from this topic, source JDBC user rewards. The key, yeah. Oh, okay. All right. That's good to know. Let me do that. Is that better? I say that when people can't see anything. Here, let me get rid of that. Is that better? All right, cool. Just interrupt me if not. All right, so I think people are watching on their phones. Folks going to go blind. All right, so here we go. With this now, it's going to source its data from this topic. The key is going to be user ID. This is super important. Every message in Kafka has a key and then the value. The key is how you're going to look this stuff up, just like a database, a primary key or something like that, right? But it's super important to understand that that key is how you're going to get that data. The value itself could be basically anything you wanted it to be. It could be a string, it could be an object, it could be some binary bits, whatever. But this key is super important. So that's going to create this. We're going to go run this inside Commander. I'm going to paste that in, run it. It says table created. Now, here's another important point to say here. A table is not a Kafka thing. When you create a table in KSQL, Kafka has no notion of a table. It only has a queue that is write only or insert only data, append only. This table indicates that KSQL is going to try and manage this for you. So if user one comes in and has a balance of 100, the next time a record hits Kafka, it might say user one 101, right? What this is going to do, because we've declared this as a table in KSQL, it's going to replace the value for that key as it comes in. So user one, when it comes in with another value, it's going to totally replace it. Again, that's not a Kafka notion. That is a KSQL notion. So just be aware of that. All right. The next thing we're going to do here is we're going to create this stream. And it's probably worth talking about this as well too. So a stream is different than a table. So again, the stream is a notion of KSQL. And what this is this is what you expect to be a transaction log stream to be, right? This is not the latest state of a record. This is truly every transaction that comes in. So they're all treated separately. If you have 1 million records that come in with user underscore one in them, then this is going to spit out 1 million records with user underscore one with no state. It's not going to aggregate state or anything like that. Again, these are just columns that come in here, and this is the topic that's going to back it, right? And here's another important thing to show here is I'm using the Avro format. I'm basically using a thing called schema registry behind the scenes. It saves the schema, just like a database would save a schema of a table behind the scenes. All the messages that come in will be bound to that schema, which is good if you want to ensure that your data you never get garbage data in, but it will fail things if you try and buck that system. So let's go ahead and paste that in. We're going to run it. I created this stream. Okay. Now, I just did the stream. So here's this one. So here I'm going to create another table, really nothing that big. Most of these now that you know the concepts behind them, this is just going to create me another table. And you can see here, I'm doing the aggregation. So this is now going to read from that rewards transactions that I created up here, that stream. It's going to listen to that stream. And as data comes in, it's going to join on that and it's going to update data with this max on the point balance, sum the points, and all that kind of stuff. So now we have something that's listening to topics in Kafka, getting data out of it, aggregating that, and then pushing it back into this new topic right here called user rewards RT balance. So did I run that? I did. So just to kind of give you guys a look at this. So look, here's that new topic that was created based off that table that I just did. And you can see here, it's creating a lot of these things for me now. So super important to be aware that those things are happening. All right. And then let's see what else we got. Okay. So right now, this is where things start getting interesting. So let's go ahead and run the select statement here. Okay, it paused. We have nothing. As a matter of fact, let's control C that. Let's do that and let's run it again. There's nothing coming in. Well, that makes sense. We haven't actually pushed any data into Kafka yet. Right now, the only place that has data is here, right? And now we should have a decent amount of data that's come in, right? So we got, yeah, we've probably got a few 100,000 transactions, something like that. So now what we need to do is we need to set this thing up to push into it. So I'm sure if you're not familiar with Postman, it's great if you need to run anything like a curl command, but you want to do it visually. And it's also great because it saves things. So the first thing I want to do here is just quickly sort of go over what we've got. So what I'm going to do is I'm going to post this to my Kafka Connect instance. So this localhost 8083, if I were to, matter of fact, let's split this out because I'm going to show you something here in a minute. We're going to duplicate, split to the right. All right. So I believe, yes, I'm in there. So if I do Docker compose PS, basically list these things out, you can see here that I've now got my Connect is running on 8083, right? And so that is where I'm going to post this thing and I'm going to create a connector. Now, the important things here, there's a bunch of configuration, but notice I'm not writing any code. So I'm basically telling it, hey, SQL Server is going to be my source. I want to connect to it, right? My username, my password, super secure stuff. Um, I'm telling it go in incrementing mode, which means that it's going to basically be watching a particular column. And anytime a higher value hits that column, then I want it to insert this stuff or grab it out of SQL Server and push it into Kafka. This is the column name it's going to be watching. Um, let's see what else we got. This is the topic that I actually want this thing to go into, and it's going to do this query every second right now. And then I define the query here, right? I'm basically telling it which columns I care about and what table it's coming from. Now, here's some interesting things. This is something to know about if you ever get into this. They have these notions of what they're called single message transforms or SMTs. So here, what I'm having it do is every message that comes through, I'm actually modifying the message as it hits this connector. So it's going to set the schema on it. And you can see here that this is metadata about how it's going to do it. But the schema name, I'm actually setting this value. And that's because of my Java application, that's what I've coded it to. The schema versions there, that's fine. I'm going to extract a value out of the record and I'm going to make it the key in Kafka. Because remember, having a key on that record is super important for the topic. So I'm extracting user ID and making that the key. And you have to do the same thing with this to make the field. It doesn't make any sense, but whatever. So I'm going to run this. So I am now set up this thing and assuming this didn't bomb. Okay. So I get something that basically mimics what I had up at the top. That's good. I'm going to do the same thing for user rewards now. I'm not going to walk through all of it because it's the same stuff. There is one thing that I had in here. It's not in this one. It's in one of the syncs that I'll show you in a little bit. So I'm going to do the same thing. One thing I will point out here is I made this one super high. Basically, I forget what it was. I'm only syncing this over to Kafka once, right? Because I think this is set up to do like a year or something. It doesn't really matter. So that's there. Let's go back over here now and let's run that same statement that I did before and check this out. I now have data coming in. And I want you to notice that it shot up this data from all the way up here and then went on. That was because I set the auto offset earliest thing. If I come back over here and I do this thing, I'm going to do this in a separate window, but I just want to show you the difference between not setting the auto offset earliest. So I'm starting this one back up and let's go ahead and run that same select statement right here. Actually, it wasn't that one. Maybe it was. What did I run over here? Okay, it's gone. Whatever. We'll just do this one. But you'll see here in a second. I don't think it was this, but whatever. Oh, I haven't created that table yet. Doggone it. It's this one. Here we go. All right. So here, if we run this, you'll see it's only getting it from now, right? It didn't go back and get all the previous records. That auto offset earliest basically said, hey, go get me everything historically. This said, hey, just pick up from where you are right now because I didn't specify that I want all the stuff from the beginning of time. So that's really important. A lot of people miss that and they get really frustrated when they're trying to go through this thing. So that out of the way, let's go ahead and close this. So I don't care about that one. Yeah, close it. Okay, so we'll go ahead and cancel that one right now. Okay, so we have data coming in. That's all good. What is this? Create table user redeem. Okay, so now we're going to start getting into some interesting things. So we just did that one, did that. Let's go ahead and create this. So this next one right here, this is where I'm trying to find out, hey, how much have you spent of your total rewards points, right? And again, it's sort of made up, but it'll demonstrate the purpose. So here we go. We're going to run that. And again, the important thing is here, it's using data already in Kafka saying, hey, that user rewards transactions, that stream that I had set up, use that, and then join the user rewards table that I have. And then we're going to grab this stuff and it's going to take those results and put them into a new topic called user rewards RT redeemed, which I think I just ran that. Yeah. So if we come back up here again, we should have this user rewards RT redeemed and it's creating that thing and it's going to start populating it and we're going to see data in here. Another thing to note here is if you use this UI, a lot of times you'll see this offset start and end. Typically, this corresponds with the number of records in it. Typically, it won't be perfect if you have multiple brokers set up, but if you're using a single broker like I am right now, that's usually what that means. So that's running. And now let's go ahead and take a look and see if we have any data in here just for this particular user. So if we run that, so check it out. Here, user 8 has a balance right now of 66.90. Before it was 66.63. Another transaction just came in. It's doing these aggregates. Another important thing to note here is even though it looks like a SQL query, you're used to, if you run a SQL query against a database, you're going to get a finite set of data back, right? That's not what's happening here. This is a streaming select. So basically, as long as I let this thing run, as soon as another piece of data hits that topic for this user underscore 8, another transaction comes in, as soon as that data gets aggregated and updated, then I'll see another record pop in here. And keep in mind, this is a table. So while this has all this in here, I could turn on compaction and eventually all this old data would fall off and you would keep and maintain the current state of that record. So that's another thing to note is this isn't exactly like a table, right? There's still all these records behind the scenes, but depending on your compaction and your retention policy in your topic behind the scenes, you could have a few records in here or only one for each user key. So really important to know, and can't go into all the specifics of all of this because this talk would go on forever. Um, and then the last thing I want to do here is I want to create the final balance, right? I want to be able to take all that work out of SQL Server and do it all here, and then we're going to give it back to SQL Server. So here we're going to create this final balance table.
We've got a question in chat.
Okay, fire away.
Why have we set the interval milliseconds too high? Will not it delay data pulling too late?
Okay, so that was only the one. So let me paste this in. So on that one, it was basically a starting point for the user rewards balance. So if I go back over here, when I created the initial data, all it was doing was bringing this over. I only ever need that once. So I basically set it at a year, right? Like if I ever needed to pull it again, I would forcefully do it. So that was it. That was only that one. The other one where it's bringing in the transactions was pulling every second. All right. So now I've created this thing. I've got this final users with rewards. And here's something to check, right? Like I can just write this. Like I know I've been pasting this stuff because I've carefully crafted all this so that I can show it for the demo. But I can say select star from uh final oops, final user rewards. And it's a oops. I mean, it's just a SQL statement. It's going to run, right? So as it went through and calculated all that stuff, I have that thing happening, right? So it tricks you into making it feel like it's a SQL system, but it's not. But it does make it to where it's a little bit easier to work with. All right, so that's all cool. We've done everything now. If we want to see some of these user transactions, wait, that's the wrong one. Let's go back here. So now let's take a look. Oh, I just did that. So what I just showed you is I showed you everybody. Let's say where user ID equal user underscore 8, right? I think that's what it was. Yeah, let's do user underscore 8. If I do that, see, and I think it's case sensitive, and that's why you copy and paste stuff. Where'd it go? Oh, it's not an underscore. So let's do this. Try and get it back up here to the top. So you can see here, we can see how these transactions affected this thing over time, right? Now, here's something interesting. What I think it's doing behind the scenes with this 0, is I think it's tombstoning some of this record and then it's inserting it back in. So it quickly kills it and then puts it back in. And this is KSQL's way of handling it. I believe that's what's happening. That's why you see the 0 zeros. All right, so that's all cool. We saw data streaming, right? We see data coming in from SQL Server. We've written zero code at this point. Like, and when I say code, I'm not talking about SQL. I'm talking about I didn't have to set up a connection from SQL Server. I didn't have to write some sort of knowledge to transfer it over to Kafka. This stuff is happening with fairly low level of effort, right? Which is really nice. So now what we want to do is let's go back over here and let's see what we've got now. So I had thought, yeah, query to get totals. So what I showed you before is still true. So we have the number of transactions that's happened for each of these users. We have the calculated point balance, which if you remember right, we're doing in our own group buys on the database. And that's all happening, right? And that's fine when you got a few thousand records. When you start getting into millions of records, that may be not so fine anymore because now you're really going to be slamming your transactional database. But this is the part we want to fix here. So as I mentioned earlier, we have data now connected from SQL Server pushing into Kafka. We need to bring that data back in. So let's go back over here to Postman. And you'll see here, I had the sources. That's where I was pushing data into Kafka. And this is actually the terminology they use, by the way. So if you want a connector that's a source that's pulling data from somewhere else and pushing it into Kafka, if you want to push data elsewhere from Kafka, it's called a sink. So here's what we're going to do. I'm going to take this and I want to set up this connector and push it back into our database. So those aggregates can now happen without me having to run these things. And again, it's really, you will see because it's a sync connector, it'll have some slightly different things, but for the most part, it's the same. You can see here, my insert mode is upsert, meaning if I don't have a user record in that table, create it. If I do have one, then just upsert the value in it. So there are some different things depending on whether you're a source or a sync connector. But outside of that, I mean, it's really not that big. So that one's created. And I'm going to go ahead while we're in here, and I'm going to set up this thing to connect to Elastic as well. And this one, you'll see that these are quite a bit different because you're not dealing with a database anymore. But the one thing I want to call out here is when you're dealing with dates across any different type of data system, and if you've been around doing this stuff for any amount of time, you know that dates are basically the bane of your existence. So in order to put this into a format that Elasticsearch likes for having a date, I'm actually doing a single message transform on this to say, hey, I know that the date format that I need is this, right? So it'll take what's here and change that. So when it goes in, that's all good. All right, did I run that? I didn't. Okay, so that is now over there. Cool. That's all good. So now let's go back over here to SQL Server and let's run this thing again. So last time we didn't have this connection set up to bring this stuff back in, but now we do. Now, check this out. These aren't exactly right now. And that's probably because the aggregates are happening at slightly separate times based off when I put things in. So even though it's not 100% perfect right now, usually it is. So maybe I had some timing stuff off when I did this. But typically, what you're going to see are these things match, because what's happening is this stuff, the streaming point balance. If we come down here and look at this, let me drag this down. The streaming point balance right here is just a join to the URRT. Let's see what we got down there at URRT. So this right here, that's coming from the real-time balance table. And if we go look at this table by itself, you'll see here, this is just a handful of records, right? These are the users that are in here with the point balance. And that is stuff that's being aggregated on the fly from the KSQL application right now that are coming into this other table. So that's actually really, really important. And again, probably some sort of timing thing I did where these aren't exactly right, but usually they're spot on. So I don't know exactly what I did here. So just take my word for it. It usually works perfectly, right? But that's really cool. So that's awesome. We now have data that's going out from SQL Server, getting aggregated by something that can scale, right? Like this thing can be scaled on its own. If you have a ton of data coming in, that work can be put off there. And then what the output of that thing is can come back into SQL Server, and you have your data there and you're good to go. Like, you take all that load off of SQL Server. So now that's all cool. But what if we wanted to bring this thing into something else like Elasticsearch, right? This is where things get really interesting, because again, in that presentation, I showed you that Kafka can sort of be your backbone, right? So now let's do this. We're going to go to Kibana, which is the front end UI for Elasticsearch. For people that haven't messed with this much, I want to explore on my own. So what I'm going to do here is I want to go to Discover. I'm going to create an index. It sees that I have this thing here. I'm going to create an index pattern on that. It's going to ask me to choose a time field. This is why it was so important in Elasticsearch. Almost everything it wants you to do is like time series based if you're doing an index. So it was important I put this into a time format that Elastic could understand. And I'm going to create this index. So when I do this now, you're going to see these are the fields that came over from Kafka, right? And so if I were to where's my search? So here we go. Here's the data exactly, right? So if we were to take a look at this, this is what got sent over in each one of these things from Kafka and are landing in Elasticsearch. And this is how much data came in at these various different time intervals, right? So that's kind of cool. That's in there. But what can we do with that? So let's go over here and let's try and create a visualization. And we will do, let's do, I have a good chart here. I could have here we go. Let's do a vertical bar. All right. So we're going to use this thing. And here, what we're going to do is we're going to add a metric, and we're basically going to say on the y-axis, wait, what happened right there? I don't want count. I basically want to do, let's do a sum. Let's do a sum, and we're going to choose the points because that's what I brought over, right? So we're going to call this user or reward points. And then down here, we'll hit play up here. We'll see some stuff up here. That's not really all that helpful. We need to create something down here. And we're going to say, we want to pull from terms. The field we're going to use is this user ID that came in. And we are going to do alphabetical. And we want to show all 10 of these. I think there might be 9, but whatever. All right. So now check this out. I should have done alphabetical. Oh, I did descending. Whatever, let's make it ascending just because I'm a stickler. So look at this. We got user 1. This is his sum of points. User 2, 3, 4, 5. So what's really cool is without writing any code so far, really outside of SQL and some other stuff, I've got data that's landing in two separate systems. It's going into SQL Server and it's now in Elasticsearch. And if I needed to do some heavy search stuff over here, I could, right? Now, granted, I don't have a ton of data coming in here right now. This is basically for an example, right? But this is data coming in on the fly. All I had to do was hook up some stuff and I have real time stuff, right? This is no longer a batch. This is no longer, hey, every hour import the data from SQL Server and push it into Elasticsearch. Hey, every midnight do this. This is all happening as the data flows through from one place to another. So this is all hooked up automatically and you can see these things changing. So that's all really cool. But there are some other meaty things I want to do. John, it looked like you were going to say something.
Yeah, we've got another question from chat.
Okay.
One question: why are we ignoring the key in Elasticsearch connector? Will it not upsert and only add into ES?
So I am ignoring the key in Elasticsearch because I don't care about it. For anybody, and I say I don't care about it for the purposes of this demo. If you're doing upserts into Elasticsearch, anybody that's ever worked with Elasticsearch a lot knows that you kind of want to treat Elasticsearch as write only if possible. And the primary reason for that is when you update a record, I don't care if you update one field on the record or you update 10, it makes an entire copy of the record. So if you can get away with it, it's a much cheaper operation to treat it as an append only thing, right? So I, again, for the purposes of this demonstration, I honestly didn't care, but in real life, just know that that can be a problem for you. And I actually have run into that trying to upsert data into Elasticsearch. Anything else before I move on to the next piece, or?
We'll check with chat as the audio catches up there and let you know.
Okay, cool. All right, so that's that. So the next part I want to do, and I think this will work. This is the fun part of. So let's open up IntelliJ. So I don't know. I'm assuming most of your watchers and users in your user group are probably C# people, right? Yeah. No. Fair to say.
More or less.
Okay. So they might.
We've
be a
got some
little bit
VB people as well. So.
Okay. All right. So you guys might all be a little bit offended that I'm opening up IntelliJ here. So before everybody tries to come after me for this one, here's a couple things to know. So I too am not a huge fan of Java. All right. So I didn't write this in Java. I wrote it in something called Kotlin. So if you ever have to take a step out into the Java world and you feel like it's way too verbose and you just can't live with it, don't feel alone. It's truly legit feeling. But what you can do is you can write it in Kotlin and it looks very much more like C#. So you see these vowels, if you're familiar with your vars in C# or whatever, instead of having to do string everything and all that, Kotlin is a much more friendly environment to code in. So I'll put that out there for anybody that ever does have to do that. And it compiles down to the same Java bytecode. So moving on from that. So let's go ahead and step through this. So I mentioned that KSQL, right? Like in that pyramid that we showed, as a matter of fact, let's bring it back up super quick. In this pyramid that we had up here, right? We said that KSQL's at the top. It was really easy. I could do these create tables, these create streams, not really hard, but you're kind of limited in what you can do there. K streams here is right in between, right? So this has the ability, and this is what it does. It is both a consumer and a producer. So it's going to listen to topics to get data, and it's going to produce data back to topics. And in K streams world, because you're writing it in Java or Kotlin, in my case, you can basically do whatever you want. You want to connect to another database, you can. It's probably not, recommended to do it that way. You want to use some sort of library out there to do extra validation on your data, like you have IP addresses and you want to take advantage of some Java library and Apache Commons library. You can do all that in this world. And that's where it's really important. So you're limited to the functions, just like SQL functions you have up here. Down here, you're limited to what kind of code you want to write. So in this, let's walk through it super quick. Up here, these are all your usings and stuff, really not that important. Whatever. This down here are just your properties to get things set up, right? Your application ID, your bootstrap servers, that's basically the Kafka brokers you're pointing to. This is just configuration stuff, right? Things that every application has. This build topology, now this is a little bit more interesting, and I don't think I was doing anything all that cool here, and I don't even think I did anything with it afterwards. But here you'll see I'm setting up my streams builder. The topic that I plan on getting data from, this input topic, I'm getting it from there, which is a configuration I'm passing in. I'm telling it that, hey, the input transactions, this is the type. So the key is a string, which I told you about. The keys are super important, especially when you're trying to join data, because this is one thing, and I should have mentioned earlier, when you're using KSQL, all those selects and those froms and those joins, be aware it's not like a SQL database where you can say, hey, I want to join user ID on this table to created by on that table. You can't do that. You're only allowed to join on the keys. So that is hyper important, because that is why keys are so important. One of the reasons it's so fast is because you're always using the key for everything. So here, the key is of type string, and my record is a user reward transaction.
Alan, can we zoom in just a little bit?
Oh, totally. Yep. Is it not Control Plus in IntelliJ? Awesome. Hold on. Let me see. Give me a second.
Can you not do Kotlin and VS Code?
I would never try and do Kotlin or Java in VS Code. Truth be told, like I love VS Code with an undying passion, but it is not a great IDE in my opinion. Let's see. Presentation.
Well, it's not an IDE. It's
right.
An editor.
It's not. It's an editor. Exactly. Is there a presentation mode? Does somebody know how to zoom in here? Hold on.
I used to.
Zoom in IntelliJ. Control all this. Open settings. Search for zoom. Here we go. Here we go. I'm getting there. Mouse wheel. There we go. Boom. Just like everything else in Windows, that shouldn't have been too hard. All right, let's kill that, kill that. All right, okay, so now people should be able to see.
Yep.
Okay, so again, this is the type user reward transaction, and I have, here's the thing. So these are the definitions of those schema files, right? And this is important to know. Right now, I basically build these Java classes based off these things right here. And that is how I'm getting this, right? If I were to go look at this thing, it generates this file, which is absolutely disgusting, right? Like, I mean, it's a lot of code, but it generates this for me. I don't have to worry about it. The next thing I'm going to do is I'm basically going to try and create this. Hey, what's the number of transactions that each user is doing? Again, not a real thing that you'd ever want to do, maybe, but here we go. So I'm grouping by the key. So user_1, user_2, it's going to give me the count of all the transactions as those flow through. And then I'm basically saying, hey, take this to a stream. So the K table, again, I mentioned that's a notion in KSQL. It's also a notion in K streams. A K table means for every key, I have one value, right? A stream is a transaction log for anything, right? It doesn't care that there is a key. And then I'm converting it back to a stream, because in order to push it back out to a topic, you have to do that. You can't just take a table and shove it into a topic. I'm going to print it out so that we can see it on the console as this thing's running. That's the only reason this particular line's in here. Otherwise, it has no value. And then I'm going to push it into the sync transactions count key value. All right, so that's going to go into another topic, and it's going to create it. And you can see here, the type for the key is a string again. The value type here is going to be a long, because I'm putting in a count. And then map, I don't remember what I'm doing here. Let's see, value, reward, count. Yeah, this is just pushing the thing out. So that's really all that's happening. The count Saturday. So without going into too much detail, this is where it's a little bit nastier to write your own. Is everything that you need to push into or get out of a topic or do any kind of transformation in, you have to have a serializer and a deserializer, and that's what Saturday stands for. So this is serializer, deserializer. So basically, this is telling this Java application, this is the type of data that I'm getting in, and this is what you have to serialize. And that is why this thing that I showed you right here is so important, this generated code based off that little JSON thing I have, because this tells it how to serialize and deserialize that data so that it can go into the topics, right? So really important. The create topics, this is so that it'll create them if they don't exist. And that's about it. Like there's really not that much that's happening here. So that's all cool, right? Like now you see the code if you wanted to roll your own and you want to do some custom things, but what does this actually mean when we go to run it? So here is where I'm going to show you some cool stuff. So I think everything I've shown up to this point is kind of cool, but now you're going to get to see some of the inner workings of how all this actually works. Okay, so some things I want to point out here, and hopefully you'll be able to see it. I will zoom in as I go throughout this, but the things that I want to show here is what I'm going to be doing is I'm basically going to be tailing the log from the broker here. Okay. And the reason is this is all cool what I've shown you, but everything so far has sort of been I have one worker out there doing something, right? So when I launch KSQL, it's doing it streaming, but it's doing it with one worker. Okay, well, what if that thing gets overloaded? How are you going to scale that out to where it can do more work? That's what I'm going to show you here. So really what I'm going to do is I'm going to spin up 5 instances of that application, that Kotlin app that I just showed you, and I'm going to run them all here. And they're all doing the same thing. Now, here's the important thing to know, because if I go back here, and I don't remember which topics it was, but let's say it was final user rewards, right? I have 5 partitions. When you're doing Kafka streams, the cool part about doing Kafka streams, if you want to do streaming technology, because there are other technologies, right? There's Spark, there's so many out there and some really popular ones. So why use Kafka streams? One of the key things is you don't need any other infrastructure. If you have Kafka running and you want to do some streaming apps, you've got everything you need. The only thing you have to do is run your jars somewhere, right? And that's super important, right? You're not spinning up a Yarn server, you're not spinning up a Spark server, you're not spinning up a bunch of other stuff. You got all the infrastructure. So that's one of the key points. Now, that being said, one of the downsides to it is your Kafka Streams apps are hyper aware of its storage layer. So in this case, you've got 5 partitions. What that basically means is the most you can parallelize the work on this is 5. So you could start up 10 instances of the application, but only 5 of them would ever do any work, right? So that is hyper important to be aware of. And that is why I wanted to show this, is you'll get to see what's happening here. So moving back over here, let's do this. Let's see if I got a tail. Docker compose logs tail follow broker. Yes, perfect. All right, so just so you're aware, so anybody that works on the command line and doesn't know this, here's a nice little tip for you. And this was probably on one of our tips of the week in coding blocks, is if you do Control R in your command line, I'm using Commander, which I highly recommend. If you do Command R, you can search for previous things. So I basically did tail here, and it will find the last command that I did. And instead of me having to figure out how to type this out or go copy and paste it somewhere, I can just hit enter. But here's the key part. I'm going to tail the logs. I'm going to get the last 100 lines from the broker log, and I'm going to follow that log. So it'll just constantly stream it. But I'm currently looking for the word rebalance. And that's important, because what I'm going to do, and you'll see this when I spin these things up, you'll see as these applications start, they're going to talk to the broker, and the broker is going to say, oh, I see that I have a new application that is wanting to subscribe to this topic, and it's going to rebalance the work and include that worker. So here we go. I'm going to tail the log, and we probably shouldn't see anything right now because there's been nothing rebalanced, right? So here we go. I'm going to Control R this one. I'm going to search for jar. And if we look at this here, all I'm doing is I'm running the Java application that I built in IntelliJ. I'm telling it to pass in the configuration dev.properties file that I have set up, which just so where is it? Dev.properties. So this is, again, just configuration information. Let's zoom in so people can see it. So this is what I'm telling it the app name is, more or less. This is the broker it's talking to. The schema registry, which again is where the schema for the data is done. The topic to pull from, the number of partitions, all that kind of stuff, right? Configuration stuff. So just know that that's what's happening. And I'm going to hit enter. All right, so this thing is going to spin up. Now check this out. That started up. We should see data flowing in over here. It's the only worker, so it's doing all the work. it's basically doing all the work across all 5 partitions at this point. So you'll see every user represented here as data comes in. Over here, when that happened, if I scroll back up, you'll see that this thing said, hey, wait a second, we have this new log thing, that we have this offset where somebody's getting ready to start, and it's going to preparing rebalance. And it says, hey, I have a new worker. I need to set this thing up to do something. So now that's cool. That's doing all the work. Let's set another one up. And we're going to do the same thing, right? So check this out. That started up. We're going to see this thing start scrolling here in a second, assuming I didn't bump it out of the way. But yeah, so check this out. Now that took over some of the work. So we have users 2 and 3 up here for sure, 1, 5, 4, 7, etc. Cool. So that's working. Let's do another one. Jar. So here we go again. We saw that bump up there. It saw that another worker joined. Now it's trying to redistribute the load, right? So user 6, 9, 7. Hopefully we'll get something down here. We may not, right? It kind of depends on how it decides to assign the work to these. We'll give it a second, see if anything comes in. 2, 3, 6, 9, 7, 4, 5. I haven't seen a 1. There's a 2. So it looks like this guy didn't get assigned anything. So now what we're going to do is we're going to do it down here and see what it decides to do with this. All right, so redistributed the load again. And we'll see this guy gets some, he's got some. Oh, he's doing something. This guy looks like he's still out in the dark. I mean, you know, it's not my job to tell it how to do it, but that's kind of what I wanted to show you here. Oops, wrong thing. Doggone it. Jar. If I do it here now, just because you have 5 workers doesn't mean that every one of them is going to be doing something. Because essentially what's happening here is you can see that this thing is getting assigned to certain partitions. And let's see. It's so big, it's actually hard to see it here. But it will tell you what partitions it's associated with. And here's the key part of it.
Make sure you zoom in for key parts, please.
Okay, yeah. Okay, so I'm hoping this actually shows up well. So yeah, as you can see here, these things are picking up, and when these things happen, so it's saying it's changing, it's using the partitions that it picked up. And let's see, well, let me scroll that here. Typically it'll tell you what the, here we go, previous active task 0_2. So that was that particular partition. And here we go, it's going to set this one to 0_2, right? So same thing down here. If I were to scroll back up, if it'll let me go that far, so you can see what partition it's being assigned to, which is 0_3. Now, here's the important part of this. There's not necessarily going to be data written to all 5 of these partitions. And this is an important part that a lot of people don't understand or don't even know about for a while. So because I set up 5 partitions, the way that Kafka writes this data out is based off how you decide to produce data to Kafka. So if you tell it that, hey, I want to hash a key a particular way and it should land on partition 1, it'll always go to partition 1. Keep in mind, I set all this up using Kafka Connect, and I don't remember exactly what the algorithm it uses is behind the scenes, but essentially it might be that because you hash these keys, that some of this data will never land on partition 3, for example, or partition 2, right? So if one of these things like this one right here is probably a good example, if I zoom in on this, you can see here, this was assigned to partition 1. There's no data in it. If I scroll all the way down here, there's nothing that's ever hit. So partition 1 is empty, right? And I think this one down here is the same thing. So if we look at what it got set to, this got set to partition 4. It's got no data in it. There's nothing being written to partition 1 or 4. But these other ones, 3, 2, and I'm assuming this was 1 up here. These all are their partition 0, so it's a 0-based type thing. So all of those have data going to them and the other 2 don't. So that's really important to know, because I get this question just about every time I do this. And people will be like, well, how do you get them on there? Well, it's kind of up to you. So one way you can do it with Kafka Connect is you can actually put a property on the record that's coming through that says partition, and you can tell it what partition to write to. So you can totally do that, right? And that could be based off some algorithm that you decide to bake into your application here, right? So you could say, hey, I know that I've got, I don't know, 10 customers, and customer one is just always hammering us with data, and the other ones don't really do that much. So you could actually tell it to balance those things as it's producing those records however you'd like. So hopefully that's helpful. We got any questions up to this point?
I don't see any outstanding questions right now, but feel free, chat room, to ask any questions and we'll make sure that they're addressed.
Yeah, because I think that's basically, actually, before I completely end it here, so watch this. So these are all running, right? That's all fine and dandy. That's good. Let's get them back to the bottom so we see what's happening. So we saw this thing bringing in data as it came in, right? Same thing here. Same thing here. All right, so everything's back to their live feed. Now watch this. We're going to kill this one. This one up here seems to be pretty chatty. It's got a lot of stuff, so I'm going to kill that. Now watch this. This is going to rebalance again because it's going to see that one of its applications died, and it's going to need to rebalance that load and push it over to these other ones. So there you go. It just did that. You can see every one of these things just started doing work. It got the same partition it had before. It did too. This one picked up a partition, 0, 0. And this one also picked up a partition, right? So the way this is made is because these are all working in parallel because they're working off separate partitions. Anytime you kill one of these things, let's kill this one because it's got 2 now. We're going to see that that thing stops. This is going to rebalance this stuff. And then these are going to start back up and pick up those partitions that should have been worked on, right? And that is really important because now you have things that are fault tolerant, right? If you think about this in some sort of Kubernetes world where you spin up these workers and you have some sort of orchestration that says, hey, I want to have 5 of these things alive at all times. Or maybe you go higher than the number of partitions. You want 7 of them alive at all time, so that if one of them dies, there's one standing there waiting, and Kafka can rebalance that work over to that thing as it goes, right? And if I wanted to start this back up again, same type thing will happen, right? We'll see this pop up. We'll see this thing say, hey, I found more stuff. We're going to rebalance it. And we'll see that happen across any one of these things that's currently running, which I don't think I'll scroll down to the bottom, so we're not seeing it. That's aggravating. So yeah, it's a really nice way to dip your toes into streaming, and be able to get some things up and running relatively quick. So I think that's basically what I've got here, and I'm totally open to any questions that anybody has. If there's anything that anybody wants to see more of here, like, help answer some of the questions that they might have bouncing around their heads right now, feel free.
So it seems like your demo here is all about the rewards cards and things like that for users, or rewards points for users. Is that a good example of a use case for this, or what would be more appropriate, or other recommendations and suggestions for this type of approach?
Oh man, so I did the user rewards thing because everybody's familiar with shopping, right? Like that was kind of the primary reason I went that route, is because everybody can think about it. I mean, honestly, there's not a great answer to that. Basically, if you can think of a world where you have data that is coming in constantly, then this could be a good platform for you, right? Like, for instance, I mentioned that Microsoft has one that handles 1 trillion events a day, right? If you think about what kind of stuff they may be tracking, right? If you're using their Office 365 tools, every action you do gets shot off over to a Kafka cluster, and then they do some sort of analysis or whatever on it, right? That's one example. Twitter, LinkedIn's a perfect example. They're the people who wrote Kafka, right? And their whole point was, we have so many things happening all the time. We need that streaming data. We need it to come in, and as it hits Kafka, there are things subscribing to it, analytical engines, right? Like there's another open source project they have called Pinot that is doing Cube, online analytical transaction stuff, right? OLAP queries and stuff. If you think about IoT is a prime example of where this kind of stuff happens all the time. So if you think about companies that have devices out in the field, right? Like, let's say, I mean, a lot of things that seem to be happening nowadays, and I think Dyson Krupp is one of them, like elevators. They put parts on elevators now, and these things like are IoT devices, and so they'll know if something's wearing or something like that, and it's constantly reporting its status back to Kafka, and then that way you could have some sort of system sitting there saying, "Hey, we got some value in from this device that doesn't look right," that can send an alert up, right? So, I mean, there are truly so many different use cases for it. It's really just changing your thinking from, um, you know, is this something that I should be doing every few hours or every night to, hey, is this stuff that we could leverage if we could do more real time? And I do want to be completely upfront, right? Like, this is not an easy mental paradigm shift, right? Like, if you have been in a database world for, a decent part of your career and you start stepping into the streaming world, it's a mind bender, because you have to think about things like, something you never think about in a database world is like late arriving data. What does that mean? You don't even care, right? If data comes in late, and by late arriving data, let's say a good example is, let's say that you're doing something on your phone, right? And you're on the cell phone network, your phone's sending messages up, right? Chances are it's hitting something like Kafka because it can handle the ingest rate. It doesn't, like, you throw some disk at Kafka and some decent speedy disk and not even crazy amounts of hardware, it can handle the ingestion. So those things are shooting messages off nonstop. However, what if that thing goes out of connection for some period, right? Like an hour, let's say it's 2 hours, right? Like, you lose cell phone service. When you connect back, it's probably going to try and shoot all those messages up. If you live in a database world, you don't care. You just have data that came in, right? If you have streams processing that's running on data that's coming into Kafka that expects it to be coming in like time wise, right? Like, hey, this happened at, right now, and then something happened a second from now, whatever. This whole notion of late arriving data, you have to figure out what you want to do with it, because is it something that you just drop and you don't use that data because you didn't have it at the time? Do you have to go back and revisit that data? Because a lot of times when you're working in these streaming systems, you're not dealing with a few thousand events or a few million. You, you're dealing with millions of events. And so going backwards in time can have implications, because you might have to keep any kind of analytics that you've been doing around so that you can keep aggregating and doing things on those. So, um, yeah, I mean, the use cases, to answer the question, the use cases are nearly limitless, right? Like, I can think of so many off the top of my head. There's actually, if I can find it, I'll share it with you later. There's a video where, of all companies, John Deere is using this stuff heavily, and it was so interesting because, I mean, you know, you see a John Deere tractor out there, somebody spent some money on it, right? Well, it's not just the tractor, it's the devices they're pulling around. Like, if you think about, farmers planting fields, as those things are going, there are sensors all over these devices that are constantly writing data that are saying, the level of the ground was this. It was able to plant it that far deep in the earth, whatever, right? Like, it was truly amazing type stuff. So, outside of just our normal tech business world, right? Like, you're working in some accounting department or something. There are uses for devices all over the place where they're using things like this and taking streaming data to say, we need to get out there and fix that thing because you're going to misplant half the field if this keeps going on, right? So, tons and tons of use cases.
Okay. And with that, do you have slides available and or code repository? It looks like there's a GitHub repo under coding blocks.
Yeah, there's one here. Oh, that's an awesome picture in the background.
Yeah, I've forked the repo under coding blocks. Hope that was the right one.
Yeah, this is it, coding blocks. Now, I did try and push the stuff up there. Apparently, my presentation was too big. I do need to update these steps, but I think most of the stuff's up there. I'm going to try and get the latest code up there here, maybe tonight. But yes, it's all here. I'll have to update the steps because, since I wrote this initially, I had these in kind of a couple different files, but I tried to streamline it so it's a whole lot easier to go step by step now, right? So, hopefully it'll make it easier for people to get in there.
All right, perfect. Well, Alan, really appreciate you joining us for stpete.net meetup. Really appreciate everyone in chat and everyone watching on their own time later on YouTube and or Twitch. Appreciate everyone taking the time to join us and watch and contribute. Please be sure to thank Alan when you see him out and about when we're allowed out of our houses. Maybe give him a quick kick to the shins as a thank you, because I hear the Coding Blocks guys like that. We're constantly looking for more presentations, more speakers, more topics. So if there's anything of particular interest to you, be sure to let us know. We'll be scheduling another virtual presentation for next month. And until we're allowed to be social in person again, that's probably the direction we'll be taking. So if there's any recommendations or suggestions to make this better for everybody, if you like this format, please let us know. If you have any suggestions or recommendations, please let us know for that as well. Be sure to follow us on Twitter. Join in on the conversations on the meetup discussion boards. Follow us on, there's a Facebook group if you're into that sort of thing, and watch us on YouTube and follow us on Twitch. Be sure to subscribe on Twitch and share with your friends and family and coworkers. But with that, I'd like to say thanks again to Alan. Thanks for Clayton for organizing all the tech for us. And with that, we'll say good night, everyone.
Thanks for having me, guys.
Good night.